To solve the issue of key distribution in the symmetric crypto systems, the public key system, also known as the asymmetric system, was introduced. In this system, each user or participant in the communication holds two keys, one public and one private. The public key is available to anyone who wants to communicate with this particular user, while the private key is kept safe and secure with the user. The private key cannot be guessed or calculated from the public key. Once someone wants to communicate with another person, they can get that person's public key and use it to encrypt their plain text messages. Upon receiving the messages, the user can then decrypt them using their private key. The public key system introduces higher complexity in its operation, due to its longer keys, therefore it requires higher computational power or longer times. One of the most famous public key algorithms is the Rivest-Shamir and Adelman. Because everyone has access to the public key, there should be a mechanism to verify the identity of the sender of a message, and to verify that the contents of the message have not been altered during transmission. Hash function is a method that derives a unique value out of a long message, sometimes called a message digest, which is then sent along with the message. The receiver can then use the hash function to derive the value from the message again, and if the two values don't match, then the message has either been corrupted or tampered with. The longer the hash value, the more probable the validity of the result. Parity is a form of hashing where only one digit can be used to verify if the message has been changed. The hash functions should be one-way, meaning that the message should not be calculable from the hash value. Some of the major hashing algorithms include the secure hash algorithm, the message digest 2, the MD4, and the MD5. The secure hash algorithm is a hash function developed by the American NIST. SHA-1 produces a 160-bit message digest out of almost any input, but due to discovered vulnerabilities, the SHA-2 was introduced, which produces larger hash values of 256 and 512 bits. The SHA-3 is the latest version of the secure hash algorithm function. The message digest 2 developed by Rivest produces a 128-bit message digest, however it has been proven that this function is not one-way, which required modification of the algorithm. Rivest enhanced the function and introduced the message digest 4 function, which produces a similar 128-bit value, but with a modified algorithm. The function has also been found weak, which resulted in the introduction of the message digest 5 algorithm, producing the same length size of 128-bit value, but with further enhancements to the algorithm. This function has also been found faulty and prone to collision, which is the possibility of having the same output for different inputs.